Hey, you're running through a vast field at night, as if something is chasing you right now. The light of the full moon brightens your path, and you see a circle of light around it. You run on looking for a safe shelter. It's not about werewolves, who are said to appear when the moon is full. Soon, this place will be the epicenter of a major storm. This very circle around the moon is called a halo, and ice crystals cause it in the sky. When the moon is full, it reflects a lot of sunlight. These rays then pass to the Earth's surface, but they curve their trajectory and split as they pass through hexagonal ice crystals. As a result, we have a halo of different colors, almost like a rainbow. The inner edge of the halo is red and the outer edge is blue. It looks beautiful, but the presence of ice in the clouds means this ice will soon turn into water and begin to fall to the ground. And this rain will be so heavy that you'd better find a shelter beforehand. If the weather is quite warm and the clouds are closer to the ground, you might see a similar phenomenon, a corona. It's much smaller than a halo, but much more colorful. The bluish-white disk on the inside turns brownish-red on the outside. Unlike halo, the corona is made of water droplets. The smaller these drops are, the larger the corona will be. If the water droplets are large, the corona will look like a bright spot the size of the moon itself. Both the corona and halo might also occur during the day when the sun is shining. But be sure to wear sunglasses before just glancing at it, because it's very bright and really bad for your eyes. As soon as you find a shelter, it starts raining heavily. Whoa, what is that? Are you being photographed? No, the flash you just saw is lightning. Bam! Thunder is so strong, the windows in the house start to shake. Here's a tip on how to tell if you're far away from the epicenter of a thunderstorm. When you see lightning, start counting. 1 1,000, 2 1,000, 3, and so on. When you hear the thunder, stop counting. Now you have to divide that number by 5. If you can count to 5, it means the epicenter of the thunderstorm is 1 mile away. If you didn't find a shelter before the thunderstorm started and it caught you in the open, leave the high ground immediately. Any mountain or hill is a high-risk area. Don't even think about hiding under a tree. Tall objects are the first target for lightning. Power poles are also at risk. If a thunderstorm catches you riding a bike, drop it immediately and run away. Same if you were riding in a convertible, golf cart, or motorcycle. If a thunderstorm started while you were in an open field, the tallest object here is you. Get down and try to cover yourself somehow. If you're not alone, try to keep your distance from each other. Whew! Now let's admire the beautiful sunrise. It looks like someone spilled red paint on the sky. This beautiful view means it's about to start raining. You can see a red sky at sunrise because the high-pressure zone has just passed you by and is now followed by a low-pressure zone with high water content in the air. So take an umbrella with you or go back to a warm bed and stay indoors. There's an old saying to keep it all straight. Red sky in the morning, sailor take warning. Red sky at night, sailor's delight. Sometimes you can even predict rain by smelling it. It's all about ozone molecules. Storm currents bring ozone down from the upper atmosphere, and when the storm is about to start, you can smell a sense of cleanliness. It's like you just washed the floor with clean water. Your sense of smell gets more sensitive before it starts to rain. It's not because of your nose, but because of the more humid air. Flowers spray their scent, and the water molecules stick to it, spreading it much better. That's why the same flowers smell different when you smell them outside or in a closed, humid greenhouse. Plants can also help you predict changes in weather. If you touch the grass in the morning and it's wet, it means it's going to be a clear day. That morning water on the grass is dew. It appears at the coldest time of night. Clear skies allow the earth to cool a bit, and the water vapor molecules in the air turn into a liquid that settles on various surfaces. Take a closer look at the leaves on the trees. Sometimes they can be upside down. For example, maple leaves respond well to increased humidity before the rain. Their stems become very soft, and the wind can turn them upside down. But the best indicator is pine cones. The seeds are inside the cone, just under its scales. The pine needs to keep them as dry as possible so that the wind can carry the seeds far away and new trees can emerge from them. So, when the pine senses rain approaching, it gives the order to close the cones. Then the scales close, protecting the seeds from the water. And instead of boring weather forecast hosts, you can just follow the animals and insects. Have you heard the crickets chirp? That will be your thermometer for today. Set the timer for 15 seconds and count how many times crickets chirp. Add 37 to that number and you get the outdoor temperature value in Fahrenheit degrees. All because air temperature directly affects crickets' metabolism. It can chirp slower and faster depending on how warm it is. So throw away your thermometer and get yourself a little friend. Now, if you don't like insects, look up into the sky for birds. If they're flying high, it'll be a clear and sunny day. But before it rains, air pressure prevents birds from flying high. You may see them flying in flocks very low, most likely looking for shelter. So even if the sky is clear, air pressure tells you that rain is coming. If you live near a river or lake, you can hear toads singing, although you can't quite make out the lyrics because it's in toad. They are especially loud before it rains hard. Toads, in general, love wet weather, so they just get excited. Rain is also the best time for females to lay eggs, so they scream loudly in search of a guy to wed. Ow! A mosquito has just bitten you. If mosquitoes are being especially aggressive, you better find a shelter fast. The insects are just trying to eat more before they have to starve during the storm. Also, the warm, humid air makes us sweat more, and we become even more attractive to mosquitoes. Insects also gather in swarms before a thunderstorm. They love the moisture in the air and start circling in a dance. But then they vanish into thin air. It means you have 1 hour left before heavy rain starts. To predict the weather for the next day, you need to watch the bees. If it rains tomorrow, the bees work overtime. They're pollinating flowers actively because they know they won't be able to leave the hive the next day because of the rain. Squirrels can predict the weather for the whole season. They usually stock up on food for the cold times. And if they start doing it early, it's going to be a tough winter. You can see squirrels running around looking for acorns. They hide them in the ground and run to find the next one. The squirrels often forget where they hid their food. These acorns turn into little sprouts, so we have many new trees, all thanks to squirrels. Animals can also predict disasters like earthquakes. Scientists once did a study in an area with frequent earthquakes in Europe. They put trackers on cows, dogs, and sheep. About 18,000 earthquakes occurred there during that time. Most of them were insignificant, but there were also 12 with a magnitude of 4 on the Richter scale. And each time, before the earthquakes, researchers recorded strange animal behavior. It was as if they were trying to escape from the earthquake zone. Scientists believe animals can sense the ionization of the air before a disaster with their fur. Their good sense of smell also allows them to smell gas. It comes from moving deep underground and then trying to find its way out through small cracks in the surface. The first records of such animal behavior date back to ancient Greece. Cats, rats, snakes, and centipedes left their homes and fled to safety days before a major earthquake hit Greece. Some fish can predict the weather in the area. If sharks hang out near the shore, they're not necessarily looking for food. They may be hiding from a big storm at sea. The worst sign on the coastline is when all the water starts to go back abruptly. You can see the entire shoreline and even the fish and coral that are left on the land. Run away immediately, because soon a huge tsunami wave will come here and wash everything away.
Count how many times the word moon is said in this video. Enjoy! There might be moons out there in space. These are moons orbiting other moons. Online, these fascinating hypothetical space objects have already been nicknamed submoons, grand moons, moonitos, moonates, and even moons. They might not exist in our solar system or any other. But some astronomers claim that the concept of a moon bringing up its own baby moon is quite plausible. The thing is, in all planetary systems we know about, natural satellites occur in a strict order. Planets orbit stars, and moons move around planets. But then, why can't submoons orbit moons? Take Earth's natural satellite. It's so massive that some astronomers even want to call it a planet in its own right. Then why shouldn't this planet-sized moon have its own satellite? In a new paper, a couple of researchers looked for a mathematical answer to the puzzle of moons. Using special equations created to show the tidal effects of planets on their moons, the scientists determined that submoons could exist if the host moon was massive enough and the submoon was small enough. Plus, there should be a wide orbital gap between these two moons and the host planet. This way, a 6-mile-wide submoon could only survive moving around a 600-mile-wide moon on a wide separation orbit. If these parameters are not met, the tidal forces of the host planet would be too powerful and would smash the moon and the moon together. Or these forces would be too weak to keep the submoon, and it would get jettisoned into space. Based on these conditions, there are quite a few natural satellites in our solar system that could hypothetically host baby moons of their own. These could be Saturn's moons Titan and Iapetus, Jupiter's satellite called Callisto, and our moon. Yes, our own moon could have its own tiny satellite. Why doesn't it? The researchers haven't found the answer to this question yet. The existence, or lack thereof, of moons may shed light on satellite formation and evolution in planetary systems. But once we find the answers we're looking for, the next logical question may arise. Can a moon have a moon of its own? If so, what name would be the most suitable for such a space body? A great grand moon? Write your variants in the comments. Besides hypothetical moons, there are loads of other bizarre things in the universe, the existence of which we haven't proven yet. Hypothetical nuclear pasta is one of them. If it does exist, nuclear pasta is the strongest material in the entire universe. It forms from the leftovers of extinguished stars when this substance gets squeezed into spaghetti-like tangles of material. It can theoretically break, but according to estimates, it could only happen if you applied 10 billion times the pressure you'd need to shatter steel. Then, there's dark matter and dark energy. We kinda know these things exist, but no one has seen them yet. Everything on Earth, and everything people can observe in space with the help of telescopes and other instruments is normal matter. It's made up of atoms and molecules and adds up to less than 5% of the universe. Almost 3/4 of the universe is dark energy. Astronomers wouldn't even know the thing existed if several decades ago they hadn't found out that the expansion of the universe wasn't slowing down. Quite the opposite. It was accelerating. It meant there had to be some enigmatic force that counteracted gravity. It was dubbed dark energy. As for about 27% of the remaining universe, it's believed that it's made up of dark matter. If dark energy is a force responsible for the expansion of the universe, dark matter is supposed to explain how objects work together. Potential candidates for dark matter vary from strange particles to super dim objects. But even though astronomers can't grasp what exactly dark matter is, they know for sure what it isn't. It's dark, which means we can rule out visible stars and planets. It also can't be dark clouds of normal matter, otherwise, scientists would be able to detect it. Dark matter is not antimatter. Astronomers don't see unique gamma rays that appear when antimatter comes in contact with matter. And neither is dark matter gigantic, galaxy-sized black holes.
You know how it all started 13.8 billion years ago with the Big Bang? Bam! No, wait, I can do better. No, never mind. And the universe has been expanding ever since. At its young age, it was all made of gas, mostly helium and hydrogen. For billions of years, the gas has expanded and cooled down. Meanwhile, galaxies, stars, and other mysterious things in space we try to explore today formed because of gravitational forces. And in that chaos, just like in middle school, about 4.6 billion years ago, our magnificent planet was born too. It all started as a disk of gas and dust that orbited the young sun, just the same way it was with the rest of the planets in our solar system. This disk consisted of dust particles of different sizes and gas. They were circling the sun at different speeds and in orbits that weren't stable and predictable. They were bumping into each other all the time. These particles grew from very small grains of dust into boulders, then later into bigger objects called planetesimals that had a range from miles to hundreds of miles in diameter. And these planetesimals that were orbiting the sun within the disk had gravitational force strong enough to pull other objects from the neighborhood out of their orbits and collide with them. As they were constantly hitting each other, they got bigger and bigger until some got to the size of thousands of miles in diameter. That's nearly the size of Mars and the Moon. We know these things because of meteorites. They come from different places all over our solar system and bring all kinds of materials to our planet, giving us something cool to study and learn about our solar system and how it formed. These materials include very small pieces of dust and rock that have gone through the chaos and survived those rough times even before the planets were created. Meteorites also brought pieces of asteroids and planetesimals left behind after the planet-forming process ended. As these objects were forming, some radioactive elements were left trapped inside the minerals that, again, were part of them. That's how scientists could tell how old they were. But the final stage of Earth's formation, and generally this whole chaos that was happening in our solar system, may have taken a little bit longer, possibly even up to 100 million years more. That's when the last enormous impact was, and the Earth finally reached its full size. What actually happened is that it hit another object which was nearly as large as Mars. This collision was so strong that the impact produced enough energy to vaporize some of the metal and rock, both from the Earth and the Mars-sized object. And this vapor created a disk that was surrounding our planet. That disk cooled and clumped together at some point, which is when we got our moon. Our moon was the result of impact debris, which was a combination of hot gas and molten rock. There are some theories of how the moon formed, though. One claims it broke off from the Earth. Another one says the moon formed somewhere else in our solar system, and at some point, as it was wandering around, it got so close to Earth that it ended up captured by its gravity. And fans of the third theory believe the moon and the Earth formed at the same time, from the same protoplanetary disk. Before the moon formed, the Earth was a much different place. If you could have just one day on Earth without the moon, you'd be first surprised by the days and nights. They wouldn't be as stable as they are today because the moon helps to keep the Earth's axis stable. Days were shorter back then. The Earth had been rotating much faster before the moon formed. Its gravitational pull slowed the rotation of our planet, which means days got longer. The Earth's rotation is getting slower through time, but at a really small rate. Some predictions say that in 1 billion years, a typical day will be between 25.5 and 31.7 hours long. If 24 hours is not enough time for you, just wait 1 billion years. But yeah, if you're the type of person that likes to take things slowly, you definitely have to hurry back then. Although there weren't many things you could do back then than to fill your time besides, sailing across the hot lava, collecting rocks, or hoping not to get hit in the head by some fierce meteorite falling onto our planet. Ow! But if you were patient enough, maybe you'd see something really cool: water coming onto our planet for the first time. There was a rain of fiery meteors coming from the sky, and they kept slamming into our young Earth. It looked devastating at first, but some of this falling debris probably held water. Many believe the asteroids and comets that bumped into our home planet carried tiny amounts of water. But considering this meteorite shower lasted more than 20 million years, maybe even up to 200 million years, it's not that unusual that after a while, puddles of water started to collect across the surface. And as the water evaporated within the atmosphere, it would fall back down, forming lakes, rivers, seas, and eventually oceans. Only at that point, there was a chance for some primitive life to evolve sometime in the future. Earth started its transition from a hot ball of magma to the world we know today. Before that, it would be too hard for life to exist there. Even if it had happened somehow, all those meteor and asteroid collisions would have probably destroyed it. Also, you wouldn't be able to survive without an oxygen tank. The Earth did have an atmosphere, but it wasn't like the one we have today. Scientists believe it was composed of water vapor, methane, ammonia, and some other gases released from volcanic activity. Basically, it was too toxic, since there were volcanic eruptions all the time. and the temperatures were way higher, so just standing at these early stages of Earth wouldn't be such a pleasant experience. Also, there could even be some form of life at that time. In its early stages, when everything was so chaotic, it wasn't covered in oceans, trees, or stunning landscapes like today, but in molten magma. I mean, the earliest form of life we know about are fossils of microorganisms found in hydrothermal vents, and they're thought to be 1.4 billion years old. And scientists assume the earliest time for life to show on Earth could be 4.2 billion years ago, give or take. So, with the right equipment, you could even see some single-celled organisms like bacteria somewhere across our chaotic planet, even before the moon was there. The moon's gravitational pull on the Earth creates tides in the ocean, which means it probably helped mix and circulate ocean water, maybe even shape them. The tides without the moon would be much smaller, because the gravitational pull is what causes the tides to rise and fall. The moon also affects life in the ocean. Over time, animals in the ocean have changed and adapted to the changing water levels caused by the moon's gravity. Even just the moonlight has a big effect on sea creatures. For example, corals use the moon's cycle to release their eggs at the same time and with stronger tides to help carry the eggs. Baby sea turtles use the moon's light shining on the water to guide them from their nests to the ocean. Who knows which directions life on the Earth would have taken if, at some point, billions of years ago, we didn't get our lunar buddy to follow us along the way.
Okay, I officially give up on the hope that the moon is made of cheese after all. Wow, not even Gouda. The shiny lunar ball, or a curved banana, or half of a coin, depending on what phase it's in, has different layers inside, just like Earth. One of these layers is called the inner core. About 20 years ago, scientists were observing how the moon rotates. Using that data, they concluded that it had a fluid outer core. But the inner core was hard to study, so they didn't know if it was solid like a rock or molten like a hot liquid. But things are clearer now. Astronomers have collected data from different missions, including the Apollo missions, where astronauts went to the moon and gathered information themselves. Plus, they've used a special technique called seismic data. This method is all about studying how sound waves move through things. Take earthquakes on our planet as an example. When an earthquake happens, it creates waves that travel through the ground. Scientists can detect and analyze these waves to learn more about Earth's interior. The same idea can apply to other objects in our solar system, or planets, or, in this case, the moon. When quakes or moonquakes happen, they generate sound waves, and by carefully listening to and studying these waves, scientists can create a detailed map of what's inside the object. They can figure out things like different layers, what they're made of, and how they're arranged. To check the moon's deep interior, scientists also use something called laser ranging. This method measures the distance between the surface of the Earth and the moon very precisely. And ta-da! Our natural satellite's inner core is a dense, solid ball made of iron, just like Earth's. It's about 310 miles wide, which is nearly 15% the size of the entire moon. Researchers also have stumbled upon evidence that supports the theory that the layer between the moon's surface and its core, called the mantle, has been moving around as the moon evolved over time. This movement is something we call lunar mantle overturn, and it could explain why we find elements rich in iron on the lunar surface. Mantle material ends up being carried upward, and the volcanic rock remains in the moon's crust. Some of the materials in this rock were too dense, like me, so they just sank back through the lighter crust material all the way to the core mantle boundary. It's like a cycle where the moon's mantle material goes up during volcanic activity, carries iron-rich elements to the surface, and then sinks back down. There's another mystery scientists have been trying to solve. What caused the moon's magnetic field to weaken and nearly disappear over time? It seems that now that we know about the iron core and the global mantle overturn, we might get some more answers about the moon's magnetic field. Knowing what the inner core is like can help us better understand the moon's history as well as the history of our entire solar system. Now, one of the theories that's widely accepted about the origin of the moon says there was a massive collision between Earth, in its early stages, and another mysterious object in our solar system. It's called the Large Impact Theory, and this collision was so strong it ripped off a big chunk of the primitive molten Earth. I mean, not so big compared to what's left. If you put a US nickel next to a green pea, you get a good idea of how big our planet is compared to the moon. Now, this chunk was set into orbit around our planet, and this might have happened about 95 million years after our solar system formed. The object that collided with Earth could have been about 10% the mass of our home planet and roughly the size of Mars. Well, it makes sense. Earth and the Moon do have similar compositions after all. Of course, there are other ideas about how the Moon formed. One says that the gravitational force of our planet captured it. This means that the Moon was just an object innocently passing by when suddenly it got attracted and pulled into Earth's orbit. There's even a hypothesis that Earth stole the Moon from Venus. Ooh. In that case, the Moon shouldn't complain. I guess the view is way better here. So yeah, the Moon and Earth are similar when it comes to rocks and some minerals. But the Moon doesn't have the same atmosphere as our planet. Its atmosphere is thin and consists of some weird gases that include potassium and sodium, which is not something you can find in the atmosphere of Mars, Venus, or Earth. And the rocks on the Moon don't contain water. But that doesn't mean there's no water at all up there. A long time ago, in the 17th century, astronomers saw large dark spots on the Moon's surface. One of these astronomers thought these spots looked like oceans, and he called them maria, which means seas in Latin. Other astronomers also made maps of the Moon, and they used the term maria to describe these dark spots. For example, Mare Tranquillitatis translates to Sea of Tranquility, where Apollo 11 made its touchdown. But it seems those dark spots are not actually oceans. They are plains made of hardened lava that erupted long ago. These volcanic eruptions left behind smooth flat areas called basalt plains. In the late 1800s, one sky watcher studied the Moon and found it didn't have an atmosphere. Without an atmosphere, there are no clouds and no air to keep water from evaporating. So scientists thought that any water on the Moon would just disappear right away. They believed the Moon was totally dry. But then, in 1961, one physicist had a different idea. He pointed out there could be water on the Moon in special areas called permanently shadowed regions. These are spots on the Moon where the sun doesn't shine, so they stay dark all the time. Water ice could exist in these dark areas because they're extremely cold and the ice wouldn't evaporate. But when astronauts from the Apollo missions went to the Moon, they brought back soil samples, and scientists found no signs of water in them. So everyone went back to thinking that the Moon was completely dry. In the 90s, NASA focused on these shadowed craters and found high concentrations of hydrogen, which meant there could be ice at the Moon's poles. They still weren't certain, so they kept digging and after a while found hydrogen trapped inside tiny beads of volcanic glass. Since there are no active volcanoes on the Moon today, which means water probably was present on the Moon when these volcanoes erupted long ago. Plus, there could be way more water back in the early days of our Moon. In 2020, NASA's SOFIA mission showed us what we'd been looking for a really long time. There is water on the Moon after all. It turns out the water is hidden within the grains of lunar dust or sticking to the surface in the sunlit areas of the Moon. So there are no oceans like we have on Earth, but at least there's something. The question remains, how did water even get there? It seems the Moon had a chaotic history back at the time when it was forming, as probably most of the planets and moons in our solar system. So there is some evidence that water came there from comets hitting its surface back in the old days, or maybe even keeps on coming from those that are slamming into the Moon right now. We're talking about a chaotic situation where icy micrometeorites collide with the Moon's surface, and dust then makes an even bigger mess when interacting with the solar wind. But we're waiting to find out more about this. because, as we all know, when you mention water, you also inevitably talk about life. That's why we want to know more, for instance, about all that ice hidden in polar craters on the moon. Maybe it can teach us more about how life developed on Earth. Maybe comets brought all the necessary elements here. Then, what if there are some of those elements stuck in the ice on the moon, too? See this? You're looking at the best full portrait of the Sun by far. Thankfully, our 4.5 billion-year-old parent star didn't use any makeup to fix its skin tone before this photo shoot. And now we can study its surface in great detail. This iconic image was taken in March 2022. NASA wanted to gain a better understanding of solar behavior and its impact on life on Earth, and the future of our space technologies, of course. To do so, they launched the Solar Dynamics Observatory Satellite, or SDO, mission in February 2010. This legendary photo shoot happened 12 years later, when SDO was halfway between the Earth and the Sun. Scientists had to assemble 25 individual images like a puzzle. So the final image contains 83 million pixels. Yeah, the resolution is about 10 times better than your fancy 4K TV screen. Look at this amazing cookie-like pattern. Typically, the bright surface of the Sun overshadows it when we observe the star from Earth. Thankfully, NASA explored the light beyond the visible range, which allowed them to discover some invisible details of the Sun's face. When you adjust your selfie with filters and effects, you can end up with completely different portraits, highlighting different spots of your face, even those you didn't know existed. The same principle works here. All these plasma balls are the same photo of the Sun, captured at different electromagnetic wavelengths. The revealed spots and patterns can help us understand events happening inside the Sun's skin a little better. At the speed of light is supposed to mean super quick. But this rose gold ray caressing your cheek at dawn has come a long way and is incredibly old in human terms. Photons generated by the Sun's core take between 10,000 to 170,000 years to travel through the star's atmosphere, and then around 8 minutes more to reach Earth. So let's explore what's taking them so long. Our tour begins with the upper layer of the Sun's atmosphere. Remember solar deities in movies and theater plays? They often wear luxurious crowns with golden rays. Well, the real Sun does wear a fancy corona too, which is the outer layer of its atmosphere. But of course, its size and glory are incomparable with those plastic costume crowns. And its shape is not so stable. Corona is a gas shell enveloping our parent star, so its size and form constantly fluctuate under the influence of the Sun's magnetic field. You can spot this crown with the naked eye from Earth during total solar eclipses. It looks like a beautiful, intense radiation around the solar disk, which itself is completely blocked by the Moon. The corona stretches 5 million miles above the Sun's surface, whereas our blue planet is only about 8,000 miles in diameter. So, one hypothetical ray of the corona equals a row of about 625,000 Earth-sized planets. And suddenly, all my problems begin to seem tiny. Now here's another fun fact. The Sun's corona kind of breaks the laws of known physics because it's hotter than it should be. Its temperature reaches 2 million degrees Fahrenheit, whereas the surface of the Sun is only about 9,000 degrees. Although the word "only" doesn't fit here, because it's still super warm in human terms. Usually temperature tends to fall as you move farther from a heat source, but it's not the case here. Space scientists are still scratching their heads trying to investigate this mystery. Thankfully, the recent photo shoot allows us to explore what's going on inside this massive hot stuff without risking losing our sight. Take these beautiful bright spots, for example. They depict solar flares happening under the corona layer. Solar flares are powerful explosions that happen when magnetic fields bump into each other. When it happens, they change shape and quickly reorganize. These fields arise from plasma, which is very turbulent itself, so these events are no surprise for the local weather. Now, who would have thought that the Sun has dark spots on its skin, just like people? These darker areas are known as coronal holes. Earthlings can experience their impact when they observe the beautiful aurora lights in the polar regions. Coronal holes look darker because plasma in these spots is cooler, less dense, and magnetically open. These conditions allow the solar winds to escape outward across the solar system rather than hang out at the sun's surface. And when they bump into the Earth's magnetosphere, auroras emerge to fascinate our eyes. Thankfully, the local fields cool down the solar winds. Nobody wants their eyes to melt, right? Now, if we were looking for an analogy to the sun's hairs, the best candidate would be solar prominences. These large, bright plasma loops arise from the sun's surface and stretch for thousands of miles into space. Their lifespan varies from days to several months. It's one of the most common events in this region. Although the first detailed description of solar prominence dates to the 14th century, modern scientists are still researching how and why they're formed. Diving further inwards, we're facing the transition region. The thickness of this layer is about 62 miles, and the local weather is unthinkable. Temperatures can rise up to 900,000 degrees Fahrenheit. The transition layer sits between the corona and the last region of the sun's atmosphere called the chromosphere. Now, speaking of which, welcome to our next stop. The chromosphere region is famous for a scientific mystery called a spicule. Come on, say it with me. Spicule. That's fun. These spectacular grassy-like jets of plasma fire upwards from the surface of the sun and reach speeds of approximately 224 miles per second, as if they're jumping on a trampoline from the surface of the sun. Each spicule lasts for just a few minutes in outer space before falling back into the solar atmosphere. Astronauts were having a challenging time trying to explain how magnetically charged particles could manage to escape the massive gravity of the sun while being so close to it. The possible answer emerged in 2017. A group of scientists discovered that neutral particles provided the magnetically charged particles with extra buoyancy to escape the solar gravity for a while, which is better than my cousin's explanation, which is happy thoughts and pixie dust. Yeah. Now let's go ahead and travel 1,000 miles inward toward the chromosphere to finally reach the solar surface, the photosphere. It's around 248 miles thick, but unlike planet Earth, the sun's surface is not solid or stable at all. The temperatures here are insanely hot for any matter to exist. On the other hand, scientists often call plasma the fourth state of matter. And why not? It's made of ionized atoms and free electrons, so it kind of deserves to matter. So what's the matter? Maybe someday we'll happen to meet the local civilization of plasmoid people. But I think it's best that we skip their welcoming warm hugs. You know, hot, hot, hot. Anyway, the photosphere is our final stop because humankind doesn't have the technology to explore the sun any deeper. So if you want to learn more, you'll have to invent your own spacecraft. But time's a-wasting. You'll only have about 7 to 8 billion years. After that, our sun will fade away, according to scientists' estimates. Actually, those same scientists will be going first. Now, you have a serious competitor, though. NASA's Parker Solar Probe is the current champion for the deepest dive into the sun. The spacecraft managed to travel 4.5 million miles from the sun's surface toward its core on September 27, 2023. And then, the Parker probe repeated its own record once again in December of the same year. So, why didn't it melt, I hear you asking? The probe has been designed to withstand insanely intense conditions and temperature fluctuations. It's equipped with a custom heat shield and an autonomous system protecting the mission from the massive solar lights. NASA has further ambitious plans. In December 2024, Parker will make its closest approach to the sun. It will travel faster than any man-made object has ever traveled, at the speed of 435,000 miles per hour. The probe will be just 3.8 million miles away from the sun's glowing hot surface. It's like landing on a star. Astronomers have already compared this epic upcoming milestone with the moon landing. I'm thinking, however, it might be safer if we, landed at night. Yeah, you're right, that's an old joke.
Astronomers have recently found a strange object far away from Earth. It disappears every 2 minutes and sends out waves of radio noise 3 times in 1 hour. It was first seen by a student named Tyrone O'Doherty while he was looking at the sky in his home country, Australia. This space object appears to be different from anything else we've seen before in space. Because of their calculated movements, scientists call these types of objects transients. Turns out, they're not that rare to find. When scientists study transients, most of the time, they look near a big star or near the things it leaves behind after it goes out. Transients come in all sorts of shapes and sizes. Some transients are slow, take a few days to appear, and stay around for a couple of months. Other transients are very fast and only appear for a second. But there are not many transients that are in between these two speeds. It's what makes this latest discovery very special and unexpected. And speaking of weird things we've found in the universe, the toughest object we know of is made from the remains of a star that has faded away. Scientists have found out through experiments that when the center of a faded star is squeezed by a lot of gravity, it turns into a type of spaghetti-like material that is extremely strong. Even if you could technically touch it with your hand and try to break it, you would need to use 10 billion times more force than it takes to break steel. Planets can be weird too. Haumea is a perfect example. This dwarf planet moves around the Sun far away from Earth, beyond Neptune. It's different from other planets because it's shaped like a sausage and has 2 small moons. It also spins very fast. One day on this planet is only 4 Earth hours long. In 2017, scientists saw something strange when Haumea passed in front of a star. They noticed very thin rings around it, which probably appeared when other various space objects were hitting each other in its vicinity a long time ago. Ever heard of a moon? It's a fancy name for a moon that orbits another moon. People on the internet let their creative side go wild with this one and gave it all sorts of different names, like submoon, moonito, grand moon, and moonette. This kind of object is just a theory right now, but scientists think it's possible that it might exist. Maybe someday we'll discover one. There are many strange moons in our solar system, like Io, which is very volcanic, and Triton, which has geysers. But one of the weirdest looking ones is Hyperion. This one is a rocky moon with many craters that looks like a pumice stone. A spacecraft called Cassini also found that Hyperion has a beam of static electricity flowing out from it. The reason for this weird activity is still up for debate. Not all stars behave the same either. When a scientist named Tabitha Boyajian and her team looked at this star, they were confused. Also known as Tabby's star, this space object would dim unexpectedly, sometimes for as much as 22%, for random periods of time. People had different theories about why this could happen, including the idea that it could be caused by another life form lurking in the universe. However, now, most people believe that the star is surrounded by a strange ring of dust that makes it look darker every now and then. Some galaxies are equally unusual. DG-SAT-1 is a type of galaxy called an ultra-diffuse one. This means that it's very big, similar to our own Milky Way galaxy, but it has very few stars and is hard to spot with regular telescopes. Scientists discovered DG-SAT-1 in 2016 and noticed that it was all by itself, which is unusual for ultra-diffuse galaxies. This means that DG-SAT-1 is very old and formed a long time ago, about 1 billion years after the beginning of the universe. NGC 247 is another weird spiral galaxy that looks almost made up. It's smaller than the Milky Way and has bright areas where new stars appear. However, there's also a dark void on one side of the galaxy's core that looks like a hole. Some theories suggest that this void could have been caused by gravitational interactions with another galaxy or a blob of dark matter. Another theory suggests that it could be the work of another civilization, building something weird in there. The Exotica catalog lists some unusual galaxies that might have big civilizations living in them. Scientists are trying to build new telescopes that will make it easier to find them. The Vera C. Rubin Observatory in Chile, for example, will be able to look at the entire sky repeatedly and see if there are any changes that could help us locate some foreign space cousins. Just in case you ever stumble upon this word, A neutrino is a particle smaller than an atom, with no electric charge and a very small mass. They are produced during nuclear reactions, such as those that occur in the Sun. Neutrinos are extremely difficult to detect because they interact with other types of matter very weakly. Scientists use large underground or underwater detectors to spot neutrinos. They study their properties to gain a better understanding of the universe and its origins. On September 22, 2017, a powerful neutrino hit Earth. This kind of thing happens often, but this one was special because scientists were able to figure out where it came from. They discovered that it was sent to Earth 4 billion years ago by a very big black hole in a galaxy that was eating up everything around it. Do you think you have an impressive jewelry collection? Wait until you hear this. Astronomers have discovered a planet that is mostly made of diamond. The planet, called 55 Cancri E, is a superplanet and is located in our Milky Way galaxy. Scientists believe that at least a third of the planet's mass is pure diamond. This is the first time a rocky planet with this kind of composition has been discovered. 55 Cancri E is very different from Earth, as it has a lot of carbon and is very hot, making it unlikely for life as we know it to exist on it. We've learned a lot of things about the universe with the help of our trusted Hubble Space Telescope. One of the most famous images taken by it is called the Pillars of Creation. This is a photo of a region of the Eagle Nebula, where new stars emerge rapidly. Captured in 1995, this picture allowed us to see massive pillars of gas and dust towering above the nebula, and has become one of the most iconic images of the universe. Some of your friends might even use it as wallpaper on their phones. The sun we spin around is a lone wolf. In reality, many stars in the galaxy have companions. Castor is one of these. It's a group of 6 stars that make up one of the brightest and most beautiful systems in the night sky. People have been looking at Castor for a long time, but they hadn't known it was actually 6 stars until telescopes and spectroscopes were invented. Even with a small telescope, you can see that Castor has 2 main stars, Castor AA and BA, that orbit each other. These stars are bigger than the Sun, and it takes them 467 years to orbit each other. Scientists from Asia found over 500 stars that are way weirder than those we've been familiar with. They move quickly around the center of our galaxy, the Milky Way. Some of these stars move so fast that they will, at one point, leave the Milky Way. The team behind the project used 2 telescopes to study these stars and properly understand their speed. These days, we call them high-velocity stars.
The moon, our little companion, our only friend in the big, dark, cold space. It's not surprising that any events related to it, like solar or lunar eclipses, excites us. But how about the black moon, the blue moon, a supermoon? Have you ever heard of them? Well, let me tell you about it and how you can observe them. Let's get your calendars ready. The distance between the Earth and the Moon is 238,900 miles, I've measured. Feels not so far, doesn't it? But trust me, most people greatly underestimate this difference. Did you know that every planet in the solar system, including Jupiter and Saturn, would fit between the Moon and us? Yeah, I couldn't believe it myself. The Moon is tidally locked to the Earth. That's why it's always turned to us with only one side. There are a few phases in a lunar cycle. The new moon is the first phase. The sun illuminates the unseen side of our satellite, so we can't see the moon. It's almost invisible in the sky. The rising moon is the gradual growth of the light part. The full moon is the phase during which the sun completely illuminates the visible side. The descending moon is a gradual waning of the light part. And finally, another new moon, and the whole cycle starts again. There are 29.5 days in a lunar cycle, so it takes around a month if we're not talking about February. But why am I telling you all this? So you can better understand Black Moon, a rare astronomical event that happens once every 29 months or 2.5 years. This term doesn't exist in astronomy, as it was made up by astrologers. It's unofficial and has several meanings. Black moon may mean the second new moon in a month. Usually there's only one new moon per month, so having two is a rare phenomenon. It's caused by a slight discrepancy between the lunar cycle and the Earth's annual one, something like leap years. Black moon can also mean something else. For example, usually there are only 3 new moons per one season. Basically, one new moon every 30 days. However, if there are 4, the black moon means the third one. There are also some less popular meanings. For example, that's what people call February without a new or full moon. This happens about once every 19 years. But what's so special about it? The satellite is wholly hidden in the sky during a regular new moon. But during a black moon, you'll be able to see its dark silhouette. You'll have to choose a good place without city lights. If you live in a big city, you'll hardly be able to see it without a telescope. Also, since the sky turns black during this phenomenon, you'll be able to see different constellations that were hidden before, as well as Jupiter and Venus. The last time this happened was on April 30th, 2022. You could observe it in most parts of the United States, except for areas in the Pacific, Alaska, or Hawaiian time. Aloha! Yeah, unfortunately, if this is the first time you hear about the black moon, you've already missed it. Now you'll have to wait another 2.5 years. The next black moon will happen in September 2024 by standard definition and May 19, 2023 by seasonal definition. But hey, don't worry. You can always see another astronomical event once upon a blue moon. Now, I'm not mocking you, I'm being serious. You can still see the blue moon. Well, not literally, of course. The moon won't turn blue. That's just what astrologers call the second full moon in a month. The black and blue moons are similar by definition, but they're actually the opposites. If the black moon is a rare second new moon in a month, the blue moon is a rare second full moon. They also both happen every 29 months. Not so rare, right? Kind of ironic that this event was called the blue moon. Folklorist Philip Hitchcock assumed that the calendrical meaning of the term blue moon was first invented by the Maine Farmer's Almanac in 1937. Now, another interesting astronomical event is called the supermoon. Stock up on telescopes and look for some hills, because you'll see an exceptionally bright and large moon, like the one we only see in movies. What exactly does a supermoon mean? You see, the moon doesn't revolve around the Earth in a circular orbit. Its orbit is elliptical, and the place where it's closest to the Earth is called perigee. A supermoon is a phenomenon that occurs when the full moon coincides with the perigee. Because of this, it seems to us especially large and bright. It looks 14% larger in diameter and 30% brighter than usual. By the way, this phenomenon is often confused with the so-called moon illusion. During the moon illusion, the moon is low above the horizon and visually appears larger in size. Of the 12 or 13 full moons in a year, 3 or 4 are supermoons, but most of them are not very significant. You probably won't see a difference at all. The most interesting ones are the rare large supermoons. During them, the moon actually becomes big. The last major supermoon occurred in 2016. Unfortunately, large-scale supermoons are rare and occur about once every 18 years. The next one will happen only in 2034, but we can observe smaller supermoons quite often. In 2022, they'll take place on June 14th and July 16th. There is also an opposite phenomenon called the micromoon. You've probably already guessed what that means. It happens when the full moon is at its farthest point from the Earth. This point is called apogee. The next micromoon in 2022 will take place on June 29th. In 2023, we'll be able to observe it on January 7th, February 5th, and August 16th. Of course, you don't have to follow each of these events. Most people are more interested in lunar and solar eclipses. By the way, are you one of the people who confuses these two events with each other? Test yourself. Pause this video, describe what these two eclipses mean. Let's compare your answer with the correct definition. Are you back? Okay. So, a solar eclipse is a phenomenon where the moon entirely or partially covers the sun. A solar eclipse is possible only during the new moon when the moon itself is not visible. Many people believe that this event is incredibly rare, but this is not quite true. A lunar eclipse is a phenomenon in which the moon is entirely or partially in the shadow cast by the Earth.
The lunar eclipse can only happen during the full moon when the proximity of the moon is on the node of its orbit. If you guess right, well done. If not, hey, don't worry. Many people confuse them. In 2022, a partial solar eclipse will occur on October 25th. It'll be visible in Europe, South and West Asia, North and East Africa, and the Atlantic. As I mentioned, a total solar eclipse is not as rare as many people think, but the problem is that it's not always visible from any part of the planet. So, if you want to see this event, be sure to look for their calendar and see from which parts of the Earth you'll be able to see it. And don't forget the special glasses. Lunar eclipses occur much more often, though. Partial lunar eclipses happen almost every month, but the total lunar eclipse in 2022 will take place on the night of November 7th to 8th. You'll be able to see it in almost all parts of the world except Africa. I hear that the zebras are not happy about this. The moon is a genuinely fascinating satellite. You think whatever, it's just a small rock ball. But in reality, there are so many interesting things connected to it. What rare lunar events have you seen or want to see in your life? Have you observed any rare and interesting astronomical events? Be sure to share in the comments.
When you explode planets, things get red hot. Atmospheres are stripped away. Stuff is flying apart. Everything collapses. The world becomes brighter than a dozen suns. You squeeze your eyes shut and cover your ears. Your hair stands on end. The sheer power of a cosmic blast is terrifying. Some time before the explosion, you're hovering in almost complete darkness. Below, you see the moon. Or what you think looks like the moon. The surface of this light-colored sphere is pockmarked with craters left by meteorites. You see huge, steep hills stretching for miles. It's Mercury, and right now, you're going to explode it. As if in slow-mo, you watch the planet fall apart. And then, in the blink of an eye, you see a wall of debris closing in on you. First, giant chunks of rock. Those are all that's left of the planet's solid crust and rocky mantle. The appearance and structure of the debris flying in your direction changes. Now, the stuff looks liquid, like splashes of quicksilver. That's Mercury's metallic core bursting apart. It used to take up 85% of the planet's volume. And finally, it's a firework of solid pieces again. It's the planet's solid core. The explosion is so powerful, it knocks Earth into a different orbit. The sun hiccups and swallows down an enormous cloud of dust. That's everything Mercury has left behind. But don't worry, our solar system won't lose any planets. This whole explosion thing is only a temporary experiment. Once you're done watching the show, you press another button, and the planet gets back together, as if you've hit rewind. You approach the next planet on your way. Its surface is hiding under a super dense atmosphere made up of carbon dioxide. If you decided to land on Venus, you'd watch thick clouds of sulfuric acid pass by. You'd see the planet's surface, reddish-brown, dry, and incredibly hot. You'd probably walk across flat, smooth plains, covering 2/3 of the planet's surface. You'd gawk at volcanoes littering Venus, all 1,600 of them. Unfortunately, you won't be able to do that because you press the button. Boom! Huge chunks of basalt fly away from the center of the explosion. That used to be the planet's 12-mile thick crust. Then you spot bright burning meteors flying towards you at incredible speed. Those are chunks of Venus's molten rocky mantle. The fire rain seems endless, maybe because the mantle was 1,200 miles thick. But that's not the most massive part of the planet. The power of the explosion forces apart Venus's metallic iron core. This core used to be twice as wide as the mantle. You reach the blue marble of your home planet. What will its insides look like, scattered in space? From above, Earth looks pretty. 71% of its surface is blue because of all that water, seas and oceans. There are also areas of green, yellow, and brown and white swirls. You press the button. The planet bursts apart in a hailstorm of rocks. They're what's left from Earth's thin crust and much, much thicker mantle. It used to take up nearly 84% of the entire planet's volume. You see the rocky rain change into something way more liquid. It's scorching hot iron and nickel that used to make up Earth's outer core. The metals weren't under enough pressure to be solid. The bang is so powerful that it takes apart Earth's inner core. It used to be a solid ball of iron and nickel. After the pieces fly apart, they follow their own orbits around the sun. The most massive chunks crash into the moon, and some travel further and get swallowed by our star. You can't linger. The red planet is waiting for you. The surface of Mars is covered with rusty-colored dust. The thickness of the dust layer varies from area to area, but in most places, it's 7 feet thick. The ground is colored gold, brown, tan, and even greenish. The hue depends on the minerals that make up the soil. The planet's surface is rocky. It's covered with dry lake beds, craters, volcanoes, and canyons. Bang! Mars is a rocky planet. You have to dodge mountain-sized chunks of crust made up of volcanic basalt rock. What you see next looks as if you've blown up huge amounts of soft, rocky toothpaste. That used to be Mars's mantle, composed of oxygen, silicates, and other minerals. And then the flying pieces get solid again. Ah, it's the planet's core's turn. It was solid, made mostly of iron, nickel, and sulfur. Billions and trillions of fragments of all sizes, from a small moon to pieces several feet wide, get launched in all directions. But only very few parts have enough momentum to leave the solar system. The whole event slightly changes Earth's orbit, and the temperature on our planet goes up by 18 degrees Fahrenheit. You leave rocky planets behind and close in on the first gas giant on your way. It's Jupiter. Thick brown, yellow, red, and white clouds hide its surface. They make the planet look colorful and beautifully striped. You hit the button. This time the view is different. Instead of chunks of solid crust, you see jet streams of gas accelerating from the planet's center. It's what used to be Jupiter's atmosphere, made up of hydrogen and helium gas. In no time, the matter hurtling away to space turns liquid. That's hydrogen changing its form under immense atmospheric pressure closer to the center of the planet. A bit later, the liquid is already a mixture of metallic hydrogen and helium. And finally, something solid. It was probably Jupiter's core, 14 to 18 times the mass of Earth. The gas giant's diameter was about 90,000 miles, but the blast lasts no more than half a second. The explosion of Jupiter is so strong, it evaporates smaller planets like Mars and Earth. The sun remains pretty much untouched. It gets hotter and kinda unstable for a bit, but it doesn't last long. The next gas giant on your way is Saturn. At first sight, it looks as if the planet has a surface. The seemingly solid yellowish-brown sphere is surrounded by layers of clouds. Saturn's trademark rings are awesome and colorful: gray, beige, and tan. They're actually groups of tiny ringlets that are made up of floating chunks of water, ice, rocks, and dust. These chunks range in size from specks to massive skyscraper-sized pieces. While orbiting Saturn, they keep colliding, and larger pieces get shattered. You're surprised to see that the rings aren't perfectly round. They have bends caused by the gravitational pull from the nearby moons. 53 of them are confirmed. Titan, an icy world bigger than our moon and even Mercury, is the largest. What you see looks eerily similar to what happened when you exploded Jupiter. There's only one difference. Saturn's rings break apart, sending rocks and ice flying into space at incredible speed. The largest pieces crash with the planet's moons, wiping away the smallest of them. You see streams of gas, mostly hydrogen and helium, with a bit of methane, ammonia, and water. They're moving at breakneck speed away from where the center of the planet used to be. After that, splashes of liquid matter. That's liquid hydrogen that later turns metallic. And finally, the chunks of the solid core made up of rocky materials. You're looking at a beautiful blue-green sphere of the ice giant Uranus. The planet gets this unusual hue when the light from the sun gets reflected off the planet's surface. Plus, Uranus's atmosphere is mostly hydrogen and helium, with traces of methane gas that absorb the red light. Anyway, bang! This time, it's massive blobs of ice that are hurtling in your direction first. They used to be the part of the planet's ice mantle that once made up 80% of the planet's volume. But why does this ice look liquid? On Uranus, frozen liquid isn't solid like on Earth. Ice is a hot, dense fluid made up of water, ammonia ice, and methane. It's often called the water-ammonia ocean. After the bizarre ice rain, you see solid pieces of the planet's rocky core. It used to be small, no more than half the Earth's mass. Some of Uranus's moons get pulverized in the explosion, and several even get ejected out of the solar system. The explosion also slightly shifts Neptune's orbit. And the last planet on your way, Neptune. It looks blue because of a layer of swirling gas and permanent clouds. No time to linger. Boom! The planet doesn't have a solid surface. That's why, after pressing the button, you see Neptune's liquid mantle bursting. It looks like a water-filled balloon thrown down from the 50th floor. This sends splashes of water, ammonia, and methane ices away into space. It's followed by lava-like remains of the planet's mantle. It used to be liquid, red-hot, and rich in methane, ammonia, and water. That's what's left from Neptune's solid core, made up of iron and other metals. The moon's surface has millions of craters, but something else has drawn a lot of attention to it. A giant rare hole that turned out to be a tube. It was found when the Japanese lunar orbiter was gathering data around the moon's skylight, the tube's entrance. Researchers found a specific echo pattern that suggested there was a hollow area. They discovered more echo patterns at a couple of places near the hole, so there could be more lunar tubes there. But in this big tube, you could place an entire football field and the pit could swallow it whole. It's irregularly shaped and 427 feet in diameter. Scientists think that there could be secret caves, a tunnel system, or an entire geological wonderland under the surface. It could be a good shelter for astronauts that land on the moon, or even be a harbor for a lunar colony. No one ever managed to stay on the moon for more than 3 days because of the conditions on the satellite. It has a wide range of temperatures, low atmosphere, and no magnetic field that would protect life on the surface from things like radiation or harsh sun rays. Astronauts wear spacesuits, but they can't protect them over long periods of time. But a lava tube could. When a lava flow cools, it gets a hard crust, which later thickens and creates a roof over that same lava. It continues to flow, but when it stops, the channel can drain, which results in an empty tube. Our planet also has lava tubes, but they're not as big as the one found on the moon. There's a special type of tree called a moon tree. It's grown from seeds that were taken into space during one of the missions and then returned back to Earth. You can find this kind of tree growing across the US. Earth is 27% bigger than the moon and far more massive. Our gravity is stronger. If you drop a rock on the Earth, it will fall faster. 150 pounds on Earth is just 25 pounds on the moon. The Earth has numerous satellites circling around it, but the moon is the only natural one. Our moon was formed during a big collision of the Earth and one more planet the size of Mars. This happened around 4.6 billion years ago, shortly after the Sun and our solar system were formed. After the collision, a cloud of vaporized rock went into orbit around our planet, cooled, and shaped into a ring of small solid bodies. They later got together and became the moon, leaving craters as a reminder of this collision. If you're standing on the surface of the moon, your shadow will be darker than on Earth. This is because there's no atmosphere to scatter light and create lighter shadows. One of Jupiter's moons, Io, has hundreds of volcanoes and pretty wild eruptions, sometimes sending plumes 250 miles into the atmosphere. These eruptions happen because of the extremely strong gravity this moon is exposed to. Its insides tense up and relax in those periods when it gets closer to and then further from Jupiter, which generates enough energy for insane volcanic activity. It's not just planets, even quite small space bodies sometimes have moons. In 1993, researchers discovered a 20-mile-wide asteroid and its 1-mile-wide moon. You'd need 400,000 moons to match the brightness of our central star, the Sun. The moon reflects the light it gets from the Sun, but it doesn't produce its own. That brightness depends on the angle between the moon, the Earth, and the Sun. Our moon is around 32 Earths away from us, and 29 Earths at its closest. When the night is dark and clear, it seems like you can touch a full moon. But if you wanted to do it, you'd have to travel up to 250,000 miles. Still, there is water on the moon. Not puddles or lakes, but grains of water ice exist in permanently shadowed parts near the moon's poles. Scientists think that water got on the moon a long time ago, during a period when both the moon and Earth were constantly struck by asteroids and comets, which contained water ice. This process may have even helped us get our own lakes and oceans, not just the moon's icy water. Newer research says that the moon's interior already had water, and it went to the surface during volcanic activity. The same might have happened on our planet too. Out of 200 moons in our solar system, our moon is the fifth biggest one. Jupiter's moon Ganymede is the biggest one, almost 1.5 times bigger than ours. Apollo 11 was the mission where humankind first landed on the moon. It was a very important moment, broadcast all over the world. But it was almost interrupted by a huge windstorm that was going on in Australia back then. Parker Dish was placed there, which was something we used to get the broadcast signals from the moon. The moon is not a perfect circle. It's more in the shape of an egg, with the thicker end pointing toward us. This shape is derived from its rotation. A full moon can keep you awake. Studies showed that people experienced less deep sleep, and it took them longer to fall asleep during the full moon period. It wasn't about its brightness, but the lunar cycle that influences our internal body clock. Each year, the moon is moving away from Earth because of the interaction between the moon's gravitational force and our oceans. In 1 year, it moves around 1.5 inches away, which means that in around 600 million years, it will be 14,600 miles further from Earth than it is now. This number isn't accidental. That's the time when total solar eclipses will stop happening. Humankind hasn't set foot on the moon in a few decades, but footprints there are still fresh because there are no winds up there, so these tracks can stay there for millions of years. The moon has its own time zone called lunar standard time. Time is different on the moon, so a year there is divided into 12 days, considering each is as long as our month. Days got named after astronauts who walked on the moon. The moon calendar starts the moment Neil Armstrong stepped onto the moon in 1969. There are possible energy sources for living beings on one of Saturn's moons. It has an ocean under the surface, and it may feature some chemical reactions similar to those that help certain forms of life on our planet survive. The moon used to have active volcanoes, probably during the time of the dinosaurs. Molten lava hardened on its surface billions of years ago, which helped create unique lunar craters, but the volcanoes have been dormant for a long time now. The moon has earthquakes, or rather, moonquakes. Just like our planet, the moon also has a crust that goes through changes and shifts. Shaking occurs when its crust warms and expands, or it can even be caused by meteorite impacts. Moonquakes are not as strong as earthquakes, but can last way longer since the moon doesn't have enough water to prevent seismic vibrations. The moon has a big range of temperatures because it doesn't have an atmosphere. During the day, it can go up to 200 degrees Fahrenheit, but at its poles, the temperature is around -400 degrees Fahrenheit. In 2019, astronauts discovered a strange space phenomenon. The moon was crossing in front of the sun, and at one moment, it seemed like it stopped and then started moving backward. It's the same optical illusion like when you're driving on the highway and pass a car that's slower than you. At one moment, as you move ahead, it may appear like it's going backward. The crust of the moon is not equally thick in all its parts. Some are up to 37 miles thick, while others are much thinner. The moon itself doesn't change colors. When sunlight goes through our atmosphere, it reflects off the moon and makes us see it as pink or red. Sometimes there are particles of dust sent into the atmosphere, and in combination with sunlight, they give the moon an orange glow. The moon doesn't have a dark side. There's only a far side that we can't see from the Earth. The moon spins on its axis once and makes a circle around the Earth, all in the same amount of time, which is why we only see its one face the entire time. All planets in our solar system have at least one moon, except for Mercury and Venus. Mercury has less mass than our planet, so its gravity is lower than ours, around 38% of the Earth's gravity. That means 100 pounds on Earth would be 38 pounds on Mercury. Because of the weaker gravity, and since it's so close to the Sun, Mercury wouldn't be able to have its own moon. It would probably crash into Mercury, or even go into orbit around the Sun, and someday even get pulled into it. Venus most likely doesn't have its moon because it's also too close to the Sun.
You hear some noise in the street and rush up to the window to check what caused it. You look up at the sky and just stand there, speechless. The moon is giant! It looks much larger than usual, and it's both beautiful and scary. So what would your life be like if the moon moved twice as close to Earth as it is now? Unfortunately, it would be quite a catastrophic scenario. You see, the moon has a pretty strong gravitational pull on Earth's oceans. It produces 2 high tides and 2 low tides per day. But with the moon so close to us, the tides would get 8 times higher. Some regions would be completely covered with water during the day. The water would only retreat at night. Many islands and highly populated coastline territories would become uninhabited because of this. Many other regions would experience frequent devastating floods. But if you think it would be the only consequence, let me tell you this. The moon also has a tidal effect on dry land. That's why if our planet's natural satellite was to suddenly relocate, its gravitational pull would increase, making waves of energy reverberate throughout the planet. This would affect Earth's crust, triggering earthquakes and starting volcanic eruptions. Now let's leave Earth and the giant moon for a while and have a look at Jupiter's moon, Io, which is the most volcanically active world in our solar system. This volcanism comes from the push and pull from Jupiter's gravity. 2 other moons of the gas giant also have an effect on poor Io. That's why Io's surface is littered with hundreds of volcanoes. Most of them are spewing sulfurous plumes high above the surface of the moon. Our planet might face the same fate should the moon move so close to it. And that's not all. Earth's spin would start to slow down over time. Look, the moon's gravity pulls the oceans, and the resulting friction between the water and the ocean floor slows Earth's spin. Yes, Earth is slowing down even now as you're watching this video, but this process is almost imperceptible, around 1/1000th of a second per century. If the moon was twice as close to us, the rotation of our planet would slow much more, making days and nights longer. If people managed to survive unexpected earthquakes, high tides, and volcanic eruptions and got used to longer days and nights, they would get an award. Solar eclipses. These spectacular events that occur when the moon passes between the sun and Earth would happen much more frequently. Since the moon would cover a much larger area in the sky, it would pass in front of the sun more often. People on Earth would be able to see the sun's outer atmosphere, called the corona. It would shine beautifully around the silhouette of the moon. Such solar eclipses would also last much longer. But what if the moon didn't shorten the distance overnight? What if it was a much slower and much more gradual process? Then our planet's crust would shift more slowly. Tides wouldn't change so dramatically either. This would let living creatures on the planet get used to the new conditions and adjust in time. Longer days and nights would likely change the climate, and animals would have to evolve to adapt to it. Their eyes would have to change to be able to deal with brighter moonlight at night. Prey would have to learn to hide better, but predators, on the other hand, would have more advantages when hunting. But what catastrophe would have to happen to make the moon move so close to Earth? Well, it could be some massive object, like a giant asteroid passing very close to the Earth-Moon system. If the moon was in the way of this space traveler, it could take energy from Earth's satellite, which would cause the moon to spiral towards our planet.